In this video, we'll be looking at Chapter 10, Section G on the cosine rule. Let's take a look at the given triangle below, triangle ABC. Notice we have angle A and opposite side A, angle B and opposite side B, and angle C, opposite side C. Now this doesn't really look like C, but notice if I have x plus C minus x, I really just have side C. And this triangle has been split into two right triangles by drawing the line CN. Now we know a few things about these triangles. Let's take a look at the left-hand triangle first, triangle ANC. And using Pythagorean theorem, we can see that b squared equals x squared plus h squared. With a little bit of rearranging, we see that h squared is equal to b squared minus x squared. Let's take a look at the right triangle now, triangle BCN. Again, using Pythagorean theorem, we see that a squared is equal to h squared plus c minus x squared. And again, with a little bit of rearranging, we see that h squared is equal to a squared minus c minus x squared. Now I have two expressions for h squared. These are the same expressions, so I can really set the right-hand side in both cases equal to each other. And now I have b squared minus x squared equals a squared minus c minus x squared. I'm going to do a little bit of algebra here. I'm going to expand this expression and I'm going to move things over and solve for a squared. So if I expand c minus x squared, I really get c squared minus 2cx plus x squared. But remember, there's a negative on the outside here. So I'm going to take this whole thing and move it over to the other side. And so I get a squared, I'm going to switch sides here, a squared equals b squared minus x squared plus this whole expression right here, which is c squared minus 2cx plus x squared. Well, notice I get a few things that simplify here. I get the x squareds cancel out, and I'm left with a squared equals b squared plus c squared minus 2cx. Now bear with me for one more second, because what I'm doing here is proving the cosine rule. And you don't necessarily need to know the proof, but you need to know the end result, which we're almost at. Let's take a look again at the left-hand side triangle, and let's find cosine of angle A. Well, we know cosine is equal to adjacent over hypotenuse. So here we have cosine of A equals x over b. Again, with a little bit of rearranging, I see that x equals b times the cosine of A. Well, I can take this expression for x and put it into this equation over here. And what that gives me is the first form of the cosine rule. I have a squared equals b squared plus c squared minus 2bc cosine A. And what this means is that if I know any two sides and the angle that's between them, the included angle, I can calculate the third side of a triangle. And again, this is the cosine rule. Now, just as with the sine rule, the cosine rule can be written in two other ways. And they are as follows. You should commit these forms of the cosine rule to memory, just like you should commit the sine rule to memory. And really, we need to remember one form. And again, I know two sides, and the angle between those two sides, I can calculate the third side of a triangle. So let's take a look at an example problem. In this problem, I have triangle ABC, and I know side AB and side AC. I also know angle A. And I'm asked to find the third side, which is the length of side BC. Now, because I know two sides and the included angle, that's a hint that I should be using the cosine rule here. Just like with the sine rule, I'm going to label the opposite sides of the triangle with the corresponding letters of the angles here. And again, I'm asked to find side A here. So that's the form of the cosine rule that I'm going to start with. A squared equals B squared plus C squared, minus 2BC cosine of angle A. And to find A, I really just need to take the square root of both sides of the equation. So now I can plug in the numbers. I know side B is 12. I know side C is 10. So I have minus 2 times 12 times 10. And multiply that by the cosine of angle A, which is the cosine of 38. Plug this all into my calculator, and I get side A is equal to 7.41 meters. In this example problem, I'm going to use the cosine rule to find an angle of a triangle. So we're asked to find the smallest angle of a triangle that has sides 9, 11, and 13. And notice how I put the shortest length on the shortest side of my triangle and the longest length on the longest side of my triangle. Now I can label the angles, and it doesn't really matter in which order I label them, but I'm going to label them like this. And remember, we're asked to find the smallest angle of this triangle. And by visual inspection, I can see that that is going to occur at angle C, which makes sense because it's the angle between the two longest sides of the triangle. Therefore, I'm going to use this form of the cosine rule. Because it includes angle C, which is the unknown that I want. And I know all three sides of the triangle. So using some algebra here, I can rearrange this equation to solve for cosine C and then the angle C. So I'm going to subtract a squared and b squared first from both sides of the equation. And then I'm going to divide by minus 2ab. And now I have an expression for the cosine of C. And remember, I can find angle C by using the inverse cosine. So if I want to find angle C, I use the inverse cosine of C squared minus A squared minus B squared all over minus 2AB. And now I have my expression written in variables, and it's just a matter of plugging in the numbers. So I have the inverse cosine of 9 squared minus 11 squared minus 13 squared over minus 2 times 11 times 13. And if I plug this into my calculator, I get angle C, which is 43 degrees, 43.0. And I could check this by using the cosine rule to find the other angles of the triangle. I could find angle B and angle A in a very similar way. And in fact, I only need to find one of the other angles, because then I could use the fact that all angles add up to 180 degrees to find the third. If I did that, I would indeed see that 43 degrees is the smallest angle in this triangle. And the great part about using the cosine rule to find an angle is that there's no ambiguous case. You only get one answer, unlike the sine rule, where you can get two answers for an angle. So if you have the choice between using the cosine rule and the sine rule, always use the cosine rule because it gives you one and only one answer.